Okay, today we're looking for discontinuities. Discontinuities means where there's some sort of, break that makes a continuous line which is smooth from negative infinity to positive infinity, and it's not smooth. We have two types: an infinite discontinuity, which is an asymptote, and a removable discontinuity, which is a hole. Here is our problem. We have x squared minus x minus 12 over x squared minus 4x. Okay, first thing we want to do is we want to factor these and find out what it is that we have. So on the top, I'm just going to do my work right here. I set it up like I would factor any trinomial. I set my variables, which I see as x. I read the signs. The second sign is negative, which means they will be mixed. My first sign is negative, which means that the negative number will be the bigger number of the two. So I put my x minus and my x plus. Now it's time to factor them. Well, I know my factors of 12 are 1 and 12, 2 and 6, 3 and 4. Okay, got my factors of 12. Now I look to see which combination is 1 apart or will add to negative 1. Well, I see that the ones that were 1 apart is 3 and 4. So I know my bigger number goes with the minus. So I set my 4 with the minus and my 3 with the plus. Okay, now just moving this over quickly, the way that I can determine what number will actually be where I would find the possibility of a whole or asymptote is I would set this equal to 0. So I've got x minus 4 equals 0. I add 4 to both sides. It's just a one-step equation, and that gives me, let's move it over here, x equals positive 4. Now, a quick way of doing that, because if the leading coefficient is 1, I can just know that this is automatically set to 0, and we just change the sign. So the number that I have on top is positive 4, and here I know that I can just change the sign. The opposite of positive 3 is negative 3. So the possible locations of a whole or asymptote would be on the top, positive 4 and negative 3. Now I go to the bottom, and I look at the bottom, and I see, I've got x and x. I've got a greatest common factor. So I want to factor that out, and my greatest common factor is going to be x. Okay, so I put my parentheses. X times x gives me x squared. Whoop, it's going to be a single x. And I bring down my minus. That doesn't change. X times 4 gives me 4x. Okay, so now on the bottom, I've got x times x minus 4. Well, I know that anywhere that there's an x, we have to set it equal to 0. Anytime I see an x by itself, that's going to be equal 0. And x minus 4, we can quickly change the sign to positive 4. And I see that I've got an x at 0 and an x at positive 4. Now, I know that to find a whole or removable asymptote, it has to repeat in the top and the bottom. Well, I have a positive 4 down here, and I've got a positive 4 up here. That repeats. Therefore, I know I have a whole at positive 4. Now, to find the vertical asymptote, I look in the bottom. Now, even though there's a negative 3 in the top, there is no negative 3 in the bottom, so I don't care about this anymore. It does not matter. However, I do have a 0 in the bottom, so what that tells me is that I will have a vertical asymptote at 0. Now, I've included horizontal asymptote, which we may or may not know now, but I see that any time that I've got x squared and x squared, so I look at the leading exponent, which is 2 over 2. When they're the same, that tells me I'm going to have a horizontal asymptote at positive 1. So I'm going to put a box around my answers here. And for this problem, I have a vertical asymptote. Let me change that. My vertical asymptote is at 0. I have a whole at positive 4, and I have a horizontal asymptote at 1. And there we are. We are done.